A dichotomous key is a tool used to identify organisms by following a series of choices that lead step by step towards the correct identification. The word dichotomous comes from Greek, meaning divided into two parts. This reflects how the key works. It offers two contrasting choices at each step. For example, has wings versus doesn't have wings. To use a dichotomous key, we select the option that best describes the organism in question. Based on the choice made, the key directs to another set of choices. By continuously choosing between two options that describe characteristics of the organism being identified, we move through the key, eliminating options until we arrive at a single identification, such as the name of the species. A dichotomous key may take the form of a table that tells you to go to question 2 or 3, etc. Here's a quick example. Let's identify these two marine organisms. We'll start with the top one. It doesn't have legs, so we go to question 3. Now, it might be a bit hard to tell in this diagram, but this organism has a soft body. Voila! We have just identified an anemone. What about the organism below? Well, it also has no legs, taking us to question 3. It has a hard shell, so this time we go to question 4. Now, if we look at the shell, we can see that it's actually not in one piece. It appears to be made instead of overlapping plates, so we have just identified a chitin. And it's as simple as that. By working through each step, we've just identified an anemone and a chitin. Now, dichotomous keys can also take on the form of a branching tree, as in this example of a dichotomous key to distinguish between certain farm animals. This is actually my preferred key. I like the branching version. Here we don't get the go to the next question and then go to question 4, etc. We just follow down through the branches. Example, if we have 4 legs on our animal, we go to the left in this example. Does it have hooves? Yes, go to the left. Does it have a woolly coat? Yes, it does. Hey, I'm talking about a sheep. Or if it didn't have a woolly coat, I go to the right. Does it have 4 toes on each foot? Yes, it does. Okay, go to the left, and I have a pig. So my farm animal, which has 4 legs and has hooves and doesn't have a woolly coat but does have 4 toes on each foot, that's the pig. So as I say, I quite like this branching version, but dichotomous keys are often given as a table version. Let's have a quick look at one more example. I have never seen this fruit before. I have no clue what it is. Luckily for me, I have this dichotomous key to identify common fruit. So let's have a look. Does the fruit have a large seed in the center? No, this doesn't. I ate a few and they certainly did not have a large seed in the center. They had multiple small seeds, so I'm going to go to step 3. Is the fruit small and grows in clusters? Well, yes, it is, and it does. We can see that in the photo. They're not very large, and they're growing in a cluster, so I'm going to step 4. Is the fruit round and purpley black? Nope, it's definitely not. Okay, so we'll try the other option. Is it red and has a bumpy surface? Yes, it is red, and it does have a bumpy surface. Oh, right, it's a raspberry. So I've just identified the fruit, raspberries, by going through this dichotomous key. Now, dichotomous keys are widely used in biology to classify and identify organisms, such as plants, animals, and microorganisms, but they can also be used for non-living objects. They help simplify complex identification processes by breaking them into manageable binary decisions. It's either this or that. And that is dichotomous keys. Sorted. Well, that's the video done. If you liked it, brilliant. Hit the like button and leave me a comment too. Now you know what to do. Go hit that subscribe button. We'll see you next time.